is a talk. I'm going to basically recap the talk that I did at DerbyCon. For anyone who's there, you've already seen this stuff, but some of you guys weren't there. So Dave also asked me to do this at 1 o'clock this afternoon, so it's good stuff. Who I am, my name is Josh Kelly. I typically go by WinFake98 on Twitter. Security engineer for Diebold. I've contributed some code to the social engineer toolkit. So the Tinsy attack stuff, some of the PowerShell stuff, I've worked with Dave on. I like to hit people with sticks. That's just some fun thing that I like to do. If you're interested, ask me about it. I'm not really going to go into that anymore. So on Twitter, you can follow me, WinFake98. So also, I'm going to try to blow through this presentation pretty fast, because I know it's the third presentation. That's not typically common here, and people probably want to leave.
Oh, come on, all the rest were short, under 30 minutes.
I'm actually shocked Dave was under 30 minutes.
Yeah, I know, right?
He originally told me it was going to be a 5-minute presentation. I knew that was a joke.
So that's what means hour.
So the way we bypass auto run right now is we use the HID devices. So the HID devices, I'm sure you guys have probably heard about them before. I have it here on this breadboard right here. It is a little microprocessor mounted on a board. It's programmed in the Arduino language. It's not an actual Arduino itself. It's called a Tinsy device. But originally it was talked about by Adrian Crenshaw, Iron Geek, last year. At DEF CON we gave a presentation about it, how we were able to use it as an attack vector. So how we were able to plug it into computers and have it automatically type out code for us, automatically type out malicious files for us and all sorts of stuff like that. You can also commercially buy these now from Hack5 if you're interested. They're about $75, $80. And it comes inside of a little thing called a rubber duck. So it's a really bad rubber duck because it's not even buoyant. But pretty much what it does is these things, they're HIDs, they're human interface devices. So they have the ability to emulate a keyboard and a mouse. This is what it looks like. This is a smaller version called a Tinsy. The version I have here on this breadboard is a Tinsy ++. So I refer to it as the DIY HID device because, like I said, you can buy one commercially from Hack5. So some of the different attack vectors that we've covered with this is, plug in, add a domain admin, or other simple commands that you can do. Execute or type out your exploit like an IE heap spray, like malicious HTML files, stuff like that, where you can compromise an Internet Explorer. Also, scripting out a reverse shell. Right there in the bottom left or right corner is just some code of a shell that I've written in PowerShell that was able to be typed out. It took only a few seconds for all these commands to run, and then from there we actually had a compromised box. Other fun things I've done with this is I like to screw with my coworkers with it. So I actually took a keyboard, modified the internal guts of it. It had a USB hub on, so I soldered a Tinsy device directly into the keyboard, put on there a little program that would move the mouse 1 pixel left, 1 pixel up, every 30 seconds or so. And it clicked too. So I thought this was going to mess with them like in Word and everything like that. It turns out it messes with them everywhere. Not only did his screensaver never come on, so we constantly were like messing with his computer, changing the background, stuff like that, flipping the computer screen upside down on him. But he got so infuriated because he thought it was his mouse moving. So he had his mouse, he had the help desk come down, change out his mouse for him. That didn't work. He thought it was the docking station for his laptop, had that changed out. That didn't fix it. Finally, he was like, okay, screw it. It's got to be the board on the computer. So changed the board out on his laptop. That didn't fix it. Went on for a week until Dave finally told me to take it out, and he brought him into his office and to talk to him while I was able to switch out his keyboard on him. After he found out what happened, he didn't talk to me for a month. He's just now talking to me. We're actually on a normal, we're friends now again.
It goes to show, bring your own external devices.
If all else fails, throw everything away and start fresh again. That's what he did. So, but other people use it to keep screensavers off. Like I said, it did it with him on accident. That wasn't the intention, but it turned out to be really funny. But some lazy sysadmin doesn't want their screen to go locked on them, so they just have it there, so it just moves the mouse every so often. So you never have to worry about typing in their password again. Embedding it in presents for family and friends, and that kind of goes back to screwing with coworkers. It's great for practical jokes. But some of the less common attack vectors, but probably the more successful ones, are brute forcing council logons. Does everyone have like a lockout policy set in their group policy and Active Directory, where your account gets locked out after every 5 tries or every 10 tries or something like that? Well, it's common on most people, but it doesn't apply to the console of the local computer. So if I'm on the computer, I can sit there and bash away at the keyboard forever, and I'm never going to lock out an account. So why should I sit there and bash away at the keyboard when I can just have the Tennessee device do it for me?
That's why on the decent systems it starts providing longer timeouts depending on how many times you've done it.
Well, that's okay. I'll just miss some parts of the dictionary that I'm trying. So that's fine. That's no problem. Inline keyboard logging and injection. We were able to get some of this proof of concept done. Iron Geek actually released the code that he had developed to get it done. So if you are handy with a soldering iron and you're familiar with taking apart keyboards, you can take apart a keyboard, plug in a Tennessee device, solder it up, and what will happen is you will type something onto your keyboard. It will get now logged into a Tennessee device, and it can interject commands while you type things. So if you're a fan of hitting Control Escape to bring up their start menu to hit run, it can now detect that you've hit Control Escape, wait for everything you typed out, and once you hit enter, it can interject commands in there. So it's really easy to interject a command into there. Say shut down shut down -R-T0 to reboot the computer real fast. Just another way to mess with people. Another way to use it as a device to get your attacks in there. Bypass USB filtering, and I'll go into that a little bit more here in a second. So bypass USB filtering. Most programs that are blocking USB devices from getting onto the computer are doing it by the VID and the PID of the keyboard. So if you're on a computer that has a Dell keyboard, let's say a certain product that Symantec has would block everything else but allow this VID, and this PID ID right here to be used on the computer. So if you just change it in the Tennessee device to these 2 addresses, and this, you can find that right here, it'll work. Here's the Apple keyboard. Your device now detects as an Apple keyboard. If you've ever plugged a non-standard Apple device into your Mac, like a keyboard, it'll automatically come up with a really annoying prompt asking you to, please tell me where the certain keys are. This gets past that, so you don't have to worry about that. So I've heard some Chinese people have done this with some attacks and stuff like that. So it's kind of interesting what else can happen with it. So executables. In order to get a binary on the system, you got to convert it into a keyboard acceptable characters. If you ever try typing out all those special characters, it's not going to work out very well for you. So what we need to do was we needed to, and this is actually out of order, really out of order. What we needed to do was we needed to convert a binary into hex. So once we converted it into hex, it's now all able to be typed out through a keyboard. And in 3 simple lines actually in Python, I can do it with this command right here. So I can convert any exe to hex and get it typed out. And then depending on the OS, I can type it out with VBScript, PowerShell, debug, Python, Perl, you name it, it's on there. We can use it to write the binary back into the hex back into a binary format and execute. So one of the problems is that with the Tennessee++, it's limited to 127K of memory. So that's all the onboard memory that I can have on there. But in truth, there's actually a 4K limit to it. So there's only like 4K that I can actually have for like strings and stuff like that. So it makes it kind of difficult. SD card was the obvious solution for this. But if I'm trying to put a interpreter shell into a Tennessee device, it's not going to work because, here it is, because the interpreter shell is actually 47K. Now, I said the Tennessee++ is 127K. The actual Tennessee itself, the screenshot that I showed earlier, is only 32K of memory. So I have all this extra memory space. My program on the Tennessee device maybe is only 9K or so, but I can only use 4K for strings. So there came to be another problem that we needed to address, which was right here. We need to use this library called PGM Space, and this is specific for Arduinos. And what this allows us to do is this allows us to put things into other spaces of memory so we can then move them out of that space of memory into the string space where we can type out the information. We actually ran into this when we were doing large HTML files that had giant heap sprays in them. We couldn't type it all out correctly, so we needed to figure out something to do. We found out about this PGM space library, and it worked out great for us. Using that, we were able to actually drop shells on the system that were already compiled for us, so we didn't have to type them out. Here is a tiny shell, is a tiny client shell. The URL that you can grab this is here, and it's 804 bytes. So this is very tiny, very quick to type out, and it works pretty well. It just, all it does is just opens up a port, connect to it with Netcat, boom, you're good to go. But the problem is that, you know, people want to use Meterpreter in a pen test. They can't really use Meterpreter because, like I said, Meterpreter right here, as you can see, is 47K. So even that's the smallest packed binary that we could get for Meterpreter. It's not really feasible to use it that way because, like I said, the original Tennessee is only 32K. The Tennessee++ is 127K. So that's where we come back to the SD card. So the SD card now is limited to the size of the SD card. So in this device right here, I have a 2 gig SD card. So that allows me to have, and it's formatted in FAT32, so I can have a 2 gig file size in there. So that's the largest file that I can have in there. Obviously, depending on how you format it, depends on how it works. But because of the library that we're using, which is the standard SD library for Arduino, it only supports FAT32. But here's some problems that we run into when we're doing large files. So we actually dumped a 47K file onto an SD card and tried to type it out. It ended up taking about 10 minutes to type out. So we're trying to type out 42,000 lines of code. It doesn't simply go fast. And these are the reasons why. Pretty much keystrokes are limited by default to all the USB devices to 500 keystrokes per second. Or 62.5 keystrokes per second. It all depends on the OS implementation of it. But that's in theory. That's maximum travel. That's maximum that you're going to get. In practice, that's really not the case because of buffers and because of all sorts of different things. If you try to type in 500 keystrokes per second into a Windows box, you're going to miss a lot of data that was supposed to be there that's not really going to go in. So what we did is we decided to use the serial libraries that are included with the Tennessee devices. So not only are we using a HID device, but we're also using a serial device now. So this way, it supports up to 12 megabits per second, which is awesome. So that means we can transfer files pretty fast. It's bidirectional, so, I mean, I know it's serial, so communication only happens one way, but we can talk to it and it can talk to us. And the best thing about this is drivers are included in all operating systems. So in your Mac and your Linux and your Windows, all of them have a serial device driver. What it's actually installing is it's installing as a USB modem. So that's how we're reading it. So why is it better? It's because we can transfer files, we can upload, download files, we can bypass device controls. You plug a serial modem into your computer, it typically does not detect as anything new or extravagant. It will do a driver installation, but it does a driver installation on everything. But auto run isn't enabled. There is no auto run on this because it's not a disk. So since it's a serial device, we need to have something on there. So one of the things that I'm working on is an executable or a script to have an interactive shell. I've got one developed partially. I need to work on it some more. And I found out the answer to how I can switch between a HID device and a serial device on these things. The best way to do it is actually have two Tennessee devices directly connected into a hub, or if I can modify the Tennessee device and make it a hub itself, and then have both devices connect in through the hub. So there I have a keyboard, I have my serial device. What I can then do is I can connect it with my keyboard, type out my shell that I want to have, my interactive shell, or my executable, or whatever I want to be able to interact with my serial device. Then I can go over to my serial device, interact with that as much as I want. But I can use the keyboard that I have, the HID device still, and be able to do this all automatically. So I can download, I can grab any file that I want to, grab anything I want to, that as long as I know the path and all that stuff ahead of time, I can do all this stuff and it'll be scripted out for me. It's just a simple plug and play device for me. But the attack, or the host machine never registers it as being an attack. So pretty much I need to know, if I'm going to a computer, I need to know if it's got something like CEP installed on it, which is going to be doing USB device restriction. I need to know what devices are restricted, what devices are allowed. So if that's the case, then I can give it the device ID, the VID and the PID of a keyboard that's approved, or of any device that's approved, and I can get onto it. So and I know I blew through this really fast. I did this in like 15 minutes, where I took like 45 minutes last time at DerbyCon. So, but any questions about this? Or did I talk so fast that you guys didn't understand me?
No, I think
Not a word, man.
I see one person shaking his head. Yeah,
No, I think it's good. The thing you said at the end about trying to switch back and forth, and I think you're exactly right. You do it as a hub. You come in as a hub, and I don't know USB line protocol well enough to know if it knows there's a hub there or if it just sees multiple device IDs. But can you write raw USB on there? I mean, I imagine you can.
Yeah, so that's part of the problem, and that's why I can't actually have one device switch between a serial device and a HID device, is because once the USB device initializes, that's where it tells the computer what it is.
So it's a hub. Like,
yeah.
Like you plug a hub in, it'll tell it on the line protocol. It'll tell it.
Yeah, it should tell it that it's a hub. So part of the problem, because I did you can write raw USB to it, but pretty much what you have to do is you have to strip away all those Arduino libraries that you're using, and you have to just do this straight in C. And I can write very basic C programs, and I can do Hello World in C. That's about it. I don't have the technical knowledge at the moment to be able to do that. But from what I looked at, though, as soon as it sees power, there are two events that happen. One event initializes the power on the device. The next event initializes the program on the device.
Do you have a USB sniffer you guys have used for this?
Yeah, I've used logical sniffers, not physical device. I've used Snoopy.
Oh, cool. Okay.
So, and I think I used, there was another one that I used, I forget what that one was called, but I was able to see it initialize. And taking a look at the actual C code inside the libraries, you can see where it initializes. And wonder if I can, like I said, I haven't really had a chance to touch this too much since I was working on it, all the way up to DerbyCon. Let's say it's maybe.
Oh, you're using the C++?
Yeah, sorry, C++.
Does it go through the Arduino tool chain?
Yeah, so
I can talk with you offline. I don't want to.
Okay.
That's cool. I mean, this is interesting, everybody. I'm just. We should talk about it. I've done a little with Arduino.
Oh yeah, absolutely.
Yeah.
It gets compiled.
That sounds really cool.
It gets compiled with the AVRC.
I just used the C. I just used the straight like C libs.
Yeah,
the restricted, so.
You can use the C libs. I was trying to go based off of what the Tinsy libraries were already developed to try to understand it.
Yeah,
and
it's a little different.
yeah, and he's using C++. He's using a mixture of C and C++.
Sure.
So, but in here there's this USB init command.
Oh yeah.
And I'm trying to find where it is. It's not in this library. So I think it's actually in here.
So you actually see in the code where it's actually initializing itself. So that's good because it's writing wrong.
Yeah.
It's not like just
Yeah,
going
so-
into some shit and saying initialize me or something. It's actually
No, and this is actually where it's getting done at. This descriptor list here. It's setting this descriptor list and setting the manufacturer product serial number,
okay.
and setting device descriptor and all this information. So with this information that it's setting, this is what's causing the device to be, and this happens upon power.
Yeah.
So you'd have to almost be able to kill the power, but change the programming before you kill the power.
Mm-hmm.
So it's
That's cool. That's cool.
yeah, it's very interesting. Me and another guy were we're working on, trying to figure it out. So does anyone have any other questions? Yes?
You said it was going through as a modem. Wouldn't it be better to just have it go through straight as a serial to make it look less suspicious?
So it's going through as a modem, and I will show you, because let me plug it into my device here, and I will show you what it's showing up as in dev. See right here? This is the device that it shows up as. So it shows up as a USB modem.
Well, the thing I'm worried about on that is it might look rather suspicious as compared with maybe a USB serial port.
Now I can change the title of this. This is all, again, this is all based off the descriptor events that are happening when I plug it in. So I can get it to be set, and again, like I said, I can change it from serial HID. I can change it to any type of USB device that I want to change it to. And even create one that's not even in
Does it
existence.
actually use any kind of modem commands, or is it
No,
just
it's not using any modem commands.
It's
So,
just-
so what I have,
So that's just what it's reporting back.
yes, and this is all controllable by the programming. So I can change this around, like it said there, USB modem 1234. I can change that to 54321, whatever.
Or phone modem to make it look less suspicious.
Absolutely.
Any number of things.
Or modem.jpeg.exe.
Yeah, I can see if I can do the reverse.
Modem.peg.exe.
I know. Sorry.
Yeah, since I have this on a breadboard, sometimes it doesn't work correctly. Okay, there it goes. So there's an actual communication string between this shell, interactive shell that I wrote and between the device itself. So I can do an ls, get a file directory listing. And this is based off the SD libraries that are included with the Arduino. So it allows me to do a file directory listing like this. And then I could do like a git.
So it's basically running the serial as if it were a file system, or as if it were...
Yeah, and that's because the Arduino program that I put onto it basically sits there and listens for these commands.
Oh, okay.
So git converts.text. This is very buggy. This is why I
It's
haven't...
like FTP.
Yeah, it essentially works like FTP. This is buggy. That's why I haven't released it, because you can see here the actual bytes of the converts.text is 147,604, and what I copied over was this.
Yeah.
So it's kind of buggy, and I don't really want to release something that buggy to people, or put it on the website and say, hey, take a look at this.
Microsoft does it all the time.
Well, yeah, Microsoft does it. I'm not Microsoft though.
Just change the descriptor.
So here's the actual Arduino code, if people are interested. But here we just initialize it. It uses the serial libraries in itself, but so it's just taking a look for just certain commands that I'm sending to it. Like
So
ls,
the
dir,
other thing I
git.
wonder on that, because you're sending through a descriptor, would any kind of drivers that are put through because of the descriptor itself interfere?
Absolutely. So that's why it's using the serial modem drivers, because those already exist and those are already there. So I don't know. You might actually be able to put it through as a because you need the serial modem drivers.
Okay.
But that would be really cool if you could say it was a keyboard but interact with
Well,
it.
that's what I wonder about, is if you could say set it up as serial and then access it via Kermit or whatever. Use what's already on the
Yeah,
system to
you
access
could,
it.
if like hyperterminal or whatever you have on there. Absolutely. That's the reason why I did install on Mac is because Python's there and it's quick and easy for me to do. The actual Python code for this, if I can go back up. What is going on?
Can you switch it around to interact as if it were running off of a separate driver, though?
It's possible. But I think that goes back into the problem of having two different devices, having two different descriptors. It's just easier to have two separate devices, I mean, instead of having one device with two different descriptors.
Well, hey, I mean, you know, a lot of these USB keyboards have 4 or 5 ports on the hub.
Yeah, that's because they have a hub integrated into them.
Exactly.
So if I can integrate a hub, then I don't really care. So.
Well, yeah, if you could do one chip with a hub and 2 teensies.
Yeah, exactly. That's what I'm going to do. I just haven't got the chance to, because of all sorts of stuff that's being thrown at me at work right now. I haven't got the chance to work on that. But here, I mean, the only thing that I'm doing is I'm just talking to it as a modem, you know, serial device. You know. So yeah, you could use hyperterminal, you could use Kermit, you could use whatever. Any other questions? No? All right. Well, thank you.